In these videos, we're going to be talking about arrays and strings in C#. So, to begin with, let's go ahead and look at how we would declare an array. The simplest type will be just an int square brackets, and then we give it a variable name, nums, and then we can initialize it with some sort of values. And notice that the IDE will automatically format this. They'll add a space there. Doesn't really matter. This is declaring an array of nums of type int with these values. Now, arrays in C# are the same as C++ and other languages where they are fixed in size. So this array of nums will only ever be 5 elements long. If we wanted to explicitly create an array of, I'll just do nums2, we can say int square bracket nums2 is equal to new int square bracket 10. And now this will create an array, and this will be an initialized array to 0. Every position will be whatever the default value for int is, to be exactly 10 elements long. So these are two different ways that you can create an array of ints. You can create an array up here which is defined as it's going to be a certain number of elements and it will be this many elements, or you can create an empty array which will be 10 elements long. You can create arrays of all sorts of different types. You can do string names, and now we can go ahead and set certain names in here. Luke, Bob, Picard. You can also do string more names is equal to new string, square brackets, 10. So this is just creating an empty array called more names of strings, which is going to have 10 elements. This is an array of 3 elements called name. You can also do char square brackets letters is equal to new char square brackets 10. For instance, you can also do float. My floats is equal to new float 10, so on and so forth. You can do that for any of these. And this syntax here, this new syntax, is very similar to how you would create something in C++ on the heap. So this will not work in C#, but in C++ you would probably say something like float my floats is equal to, actually you would need a asterisk there, sorry, is equal to new float 10, for instance. And this would create an array on the heap, it would be a pointer to that, of 10 elements. This is doing the exact same thing. So C# does have a stack and a heap, but you can't explicitly state, I want to create this on the stack, I want to create this on the heap. Instead, the compiler automatically figures out where things should go. So when you create an array, what it does is it creates on the stack a pointer. It creates actually an object, and that object is a pointer to the array on the heap. So that's also why arrays, and we'll talk about these later with methods, arrays are always passed by reference because they are a reference type, whereas regular variables are values, and so those are declared and allocated on the stack. When you use this new keyword, that means that, hey, we're going to create it on the heap. Well, all we have on the stack is going to be a pointer to the actual array, which is going to be on the heap. So just keep that in mind that there is a stack and a heap, but the compiler automatically handles where things go. And so when you created something like this in C++, once you're done with it, typically you would have to do delete square brackets my floats to actually free up that memory. Well, C# has garbage collection, and so once you are finished with this, it automatically frees up that memory. and sends it to the garbage collection. So you don't have to do this anymore. All you have to do is just declare it and create it like that. Now, accessing elements in the array is exactly the same as other languages. So let's go ahead and deal with this up here. So we'll go ahead and say console write line, and I'm going to use the string interpolation. First element in nums is curly brace nums square brackets 0. So just like everything else in, well, programming and computers, things start at 0. So if we were to run this, we would get the first element in nums is 1, which is going to be that number there. If we want to get the second element, well, this would be just index 1. And so this should print out 1 and then 2 to the screen. 1, 2. And we can go through all of those like that. Now, if you try to go beyond the end of the array, notice that we put a 5 there, and even though there's 5 elements, it goes 0 to 4, we're going to get an unhandled exception, system index out of range exception. So it will complain when you try to go beyond the end of the array. Now, one of the really cool things, so let's take this array for example. If you want to get the last element in the array, in C++, you would have to know how many elements there are and then print out the last one there. So it would be, let me go ahead and duplicate this. The last element in nums is, and then this would be whatever the length of that is. So in this case, we know that there are 5 elements there. So this would be basically 5 minus 1 to get to 4. And when we run this, then we will get out 5 here. Now C# has a really cool feature to where you can actually type in !1. And this will be the last element in the array. So if you're familiar with Python, typically you would put -1 there. In C#, you just put a caret there. So now when we run this, notice that now we get the last element in nums is 5. And we can do the, let's say, the next to last element is going to be 2. So notice that now we get a 4 out there. And in fact, if we know what the length of this is, if we do !5, that will be the first element. And so using this caret, you can actually go backwards through the array pretty quickly and pretty efficiently. Changing elements in the array is handled exactly the same. So let me go ahead and comment this out and comment this out. So the first element in nums is that, and we'll go ahead and set nums square brackets 0 is equal to 42. And we'll go ahead and copy this and paste that down there. And now when we try to access the first element, we get 42 for that first element because we changed the value right there. So arrays in C# function almost exactly the same as they do in C++. The difference is, well, this is going to create on the heap. This is actually also going to create on the heap. It just doesn't explicitly show you that. This is a little bit more explicit. And you can use caret and then the number to go backwards through the array.